Welcome back, listeners, to a brand new deep dive. I've always been fascinated by, like science and stuff, and I thought this would be a fun one. You know how sometimes sometimes they say they don't trust atoms
Oh, really? Why is that?
because they make up everything.
That's a good one.
I'm Hari, and this is Kimi, and we're going to take a deep dive into the sun today.
That's right, Hari. We've got a ton of information about the sun here. Everything from its physical characteristics, like how big it is and what it's made of, to, how it's been seen in different cultures throughout history.
We're going to try to break it all down for you and give you the most interesting and important insights about the sun, without totally overwhelming you with information. So let's just get right into it, shall we?
Sounds good to me.
So first off, the sun, it's basically like a giant ball of really hot plasma, right?
Right, yeah, plasma. Basically, it's like atoms, but they're so hot that their electrons have been stripped away and it's all held together by like really strong gravity, and nuclear fusion is going on in its core, which is like the source of all its energy. It's pretty mind-blowing, actually.
It really is. And, that energy is what makes life on Earth possible. I mean, think about it. The light we see, the heat we feel, even the weather patterns, they're all driven by the sun's energy. It's like the ultimate life giver. And I guess it's no surprise that so many cultures throughout history have worshipped the sun as a god.
Yeah, definitely. The sun has always been like this central figure in mythology and religion, like the Egyptian god Ra or the Greek god Helios, bringing light and warmth to the world. And of course, it's also been a major focus of astronomical research for centuries. I mean, how could you not be fascinated by something that's so big and powerful and mysterious?
Okay, so speaking of size, let's put this into perspective. The sun is huge. I mean, really, really huge. It's something like 109 times the diameter of Earth, which is just mind-boggling. And its mass, get this, is 330,000 times greater than Earth's. And here's the kicker. It accounts for 99.86% of the total mass of our entire solar system.
That's a lot of mass, right? And all that mass is mostly made up of two elements: hydrogen and helium. It's 73% hydrogen and about 25% helium. And then a tiny, tiny fraction of heavier elements like oxygen, carbon, neon, iron, that kind of stuff. And astronomers call that the metallicity, which is a bit of a weird term, but it basically tells you, how much of the sun is made up of those heavier elements. And for the sun, it's really low. 0.0122 is the number.
So I've always heard the sun called a yellow dwarf star. Is that scientifically accurate?
Well, not really. You see, it's actually classified as a G-type main sequence star, or more specifically G2V, which is where that yellow dwarf term comes from. But if you could actually see the sun's light without the Earth's atmosphere filtering it, it would appear white, not yellow. The yellow color we see is because, the Earth's atmosphere scatters the shorter wavelengths of light, like blue and violet, more than the longer wavelengths, like yellow and red.
Interesting. So how did this massive white hot ball of plasma actually come into existence?
So the sun formed billions of years ago, around 4.6 billion years to be exact. And it all started, in a giant cloud of gas and dust, a molecular cloud. And this cloud, it was massive and cold. And then something happened, probably a shock wave from a nearby supernova, that kind of thing. It caused this cloud to start collapsing in on itself due to its own gravity.
So as it collapsed, it got denser and hotter and hotter and hotter. And eventually, bam, nuclear fusion kicked in.
Exactly. The core got so hot and dense that hydrogen atoms started fusing together to form helium, releasing a tremendous amount of energy in the process. And that's what powers the sun. I mean, think about it. Every second, the sun is converting 600 billion kilograms of hydrogen into helium. And in doing so, it's turning 4 billion kilograms of matter into pure energy. That's E equals mc squared in action right there. It's mind-blowing.
It's totally amazing. But everything has an end, right?
Oh.
What's going to happen to the sun eventually?
Right. So the sun is middle-aged right now. It's been around for about 4.6 billion years, and it's got about another 5 billion years or so left in its main sequence phase. But eventually it's going to run out of hydrogen fuel in its core. And when that happens, things are going to start changing. The core will contract and heat up, causing the outer layers to expand and cool. And the sun will become a red giant star. It will engulf the inner planets, Mercury, Venus, maybe even Earth. It's still debated, but it's going to be a pretty dramatic event.
Wow. That's kind of terrifying, but also kind of awesome to think about. So after the red giant phase, what happens then?
Well, eventually the sun will shed its outer layers, creating a beautiful expanding shell of gas and dust called a planetary nebula. And what will be left behind is a dense, hot, stellar remnant called a white dwarf. That's basically the dead core of the sun, slowly cooling down over billions and billions of years. And, like theoretically, it could eventually become a black dwarf, but that would take like trillions of years, much longer than the current age of the universe. So we don't actually know for sure if black dwarfs even exist yet.
That's fascinating. It's amazing to think about the sun's whole lifespan, from its birth in a cloud of gas and dust to its final fate as a white dwarf, or maybe even a black dwarf. It makes you realize how dynamic and ever-changing the universe is.
It does. I mean, even the word sun itself has this long and fascinating history. It comes from the Old English word sun, which in turn comes from the Proto-Germanic word sunno.
That's seriously old school. But it makes sense, right? The sun's been around for so long, it's only natural that its name would have deep roots in human language. And we use the word sun in all sorts of ways, to describe things that are bright or warm or sunny. It's a word that's just full of positive connotations.
Yeah, for sure. And then there's the symbol for the sun, which is a circle with a dot in the center.
Oh yeah, I've seen that, in science textbooks and stuff.
Right. And it's used in all sorts of astronomical units like solar mass, solar radius, solar luminosity, ways of measuring things relative to the sun. And the study of the sun itself is called heliology, which comes from the Greek word for sun, helios. It's a whole field of science dedicated to understanding our star.
It's incredible how much we've learned about the sun, from its composition and structure to its magnetic activity and its long-term evolution. But there's still so much we don't know. How exactly is the sun's magnetic field generated? And why is the corona, the sun's outer atmosphere, so much hotter than the photosphere, its surface?
Yeah, there's this mystery called the coronal heating problem. I mean, the corona can reach temperatures of millions of degrees, while the photosphere is only a few thousand degrees. So how does that even work? There are theories, of course, but it's still an active area of research. It's one of the big unsolved puzzles in solar physics.
It's amazing to think that something we see every day, something that's so familiar, can still hold so many mysteries. But I mean, that's what makes science so exciting, right? The constant pursuit of knowledge and understanding.
Yeah.
So back to the sun's place in the universe. Where exactly is it located in the Milky Way?
Okay, so we're located in the Orion arm of the Milky Way galaxy, which is a spiral arm that's between the Sagittarius and Perseus arms. And the sun, it's orbiting the center of the galaxy, right? But it takes a long time to complete one orbit, about 225 to 250 million years.
Wow, that's longer than dinosaurs roamed the Earth.
Exactly. It's a really long time. And the sun's not just orbiting the galactic center, it's also moving through space relative to other stars and galaxies. For example, the closest star system to us is Alpha Centauri, which is a triple star system about 4.4 light years away.
Okay, so we've covered a lot of ground here, from the sun's basic properties to its formation and evolution and its place in the Milky Way. Now, I think it'd be cool to take a step back and look at how our understanding of the sun has changed over time.
Okay, so way back in the day, the Babylonians, they were really good at observing the sky, and they noticed, the sun's daily and yearly movements, and they even developed calendars based on those movements. But they didn't, understand what the sun was or how it worked.
And then came the Greeks, right?
Yeah, the Greeks, they were really into philosophy and trying to explain the universe, in a logical way. And there was this guy, Aristarchus of Samos, who was actually the first person to propose a heliocentric model of the solar system, back in the 3rd century BC.
Wait, so he figured out that the Earth revolves around the sun, way back then? That's incredible. But I thought Copernicus was the one who came up with that idea.
Well, Copernicus did rediscover the idea and popularize it in the 16th century. And then Galileo came along and made those amazing observations of sunspots with his telescope, which helped to prove that the sun wasn't this perfect unchanging sphere like people had thought before.
So how did we go from thinking that the sun was this, perfect unchanging sphere to understanding that it's actually a giant ball of hot plasma powered by nuclear fusion?
Well, it was a gradual process. A lot of scientific discoveries build on each other. So in the 19th century, there were these physicists, Lord Kelvin and Hermann von Helmholtz, who proposed that the sun's energy came from gravitational contraction, which was a good idea at the time, but it couldn't explain the sun's age. And then Ernest Rutherford came along and suggested that maybe radioactive decay was the source of the sun's energy. But it was Einstein's theory of special relativity with the famous E equals mc squared equation that really paved the way for understanding nuclear fusion.
Right, E equals mc squared. That's like the most famous equation in physics. So how did that equation help us understand the sun?
Well, E equals mc squared basically says that energy and mass are equivalent, like they can be converted into each other. And that was like a revolutionary idea. And it led to the realization that the sun's energy could come from the fusion of hydrogen into helium, which is like a process that converts a tiny amount of mass into a huge amount of energy.
And so, like, the mystery of the sun's energy source was finally solved.
Pretty much. But, there are still details to work out, like exactly how nuclear fusion works in the sun's core. And then there's like all the research into the sun's magnetic field, solar flares, coronal mass ejections, all that stuff. It's a really active field of research.
Mm. So let's talk about those solar missions, like the ones that have been sent to study the sun up close.
Oh, yeah. There have been so many amazing missions over the years, like the Pioneers, the Helios probes, Skylab, the Solar Maxima mission, Yoko, SOHO, Ulysses, Genesis, and more recently, the Parker Solar Probe, which is actually like flying through the sun's corona.
That's, like, seriously impressive. I mean, the sun is so hot, how can a spacecraft even survive that?
Well, it's designed to withstand like extreme temperatures and radiation. It's got special heat shields and all sorts of advanced technology. And it's sending back like incredible data about the sun's magnetic field, the solar wind, like all sorts of stuff.
Okay, I have to ask, is it ever safe to look directly at the sun?
Absolutely not. Looking directly at the sun, even for a short time, can cause serious eye damage. You should never, ever look directly at the sun without proper eye protection, like special solar filters or eclipse glasses.
Good to know. But what about, like, that green flash you sometimes see at sunset? Is that safe to look at?
Well, the green flash is like this really cool optical phenomenon that happens, like when the sun is setting or rising. And it's safe to look at, but it's very brief. It only lasts for a few seconds. And it happens because, like the Earth's atmosphere acts like a prism, splitting the sunlight into different colors. And under certain conditions, you can see this green flash as the last bit of the sun's light disappears below the horizon.
That's amazing.
Yeah.
Okay, so we've talked about the sun from a scientific perspective, but it's also been, like, a huge part of human culture and mythology
Yeah.
for, like, as long as humans have been around.
Right. The sun has been worshipped as a god in so many different cultures. Like the ancient Egyptians had Ra, the god of the sun, who traveled across the sky in his solar boat. And the Greeks had Helios, who drove his chariot across the heavens. And the Romans had Sol Invictus, the unconquered sun, who was associated with victory and power. And there are so many other examples from all over the world, like the Aztec sun god Tonatiuh, the Shinto sun goddess Amaterasu. The list goes on and on.
It's incredible how the sun has inspired, like, so much art, literature, and mythology throughout human history. It's like this universal symbol of, like, light, warmth, life, power, and, like, so much more. It's amazing how something that's so, like, scientifically complex can also be so deeply meaningful to people on a personal and cultural level.
I know, it makes you think about our place in the universe. Like we're just this tiny little planet orbiting this giant star that's been around for billions of years, and yet it has such a profound impact on our lives.
Well, on that note, I think it's time to wrap up this deep dive. We've covered, like, a ton of information today, from the sun's physical properties to its formation and evolution, its magnetic activity, its place in the Milky Way, and its role in human culture and mythology.
Yeah.
It's been like a whirlwind tour of everything sun-related, and I hope you've all learned something new and interesting.
Me too. And I think the most important takeaway is that the sun is a truly incredible object. It's a massive dynamic star that powers our entire solar system and makes life on Earth possible.
And even though it's, like, millions of miles away, it still plays such a central role in our lives, from the way we measure time to the way we experience the world around us.
I think it's a reminder that we're all connected, like we're all part of this vast and amazing universe.
And on that note, we'll leave you with one final thought to ponder. Given the sun's inevitable transformation into a red giant billions of years from now, what are the long-term implications for our solar system and for the future of life, if any, that might still exist on other planets?
It's a question that's both fascinating and, well, a little bit scary, but it definitely makes you think about the big picture, the long-term fate of our planet and our place in the cosmos.
Thanks for joining us on this journey of discovery. Until next time, keep exploring, keep asking questions, and keep looking up at the stars.